This is the introduction to Unit 1.3, Angle Relationships. There's a lot of vocabulary in this unit. Luckily, you already know some of it. The first word, though, we're going to point out is the word transversal. You'll see this word a lot. So a transversal is a line that intersects two coplanar lines at two distinct points. So if you look at this first diagram, this purple looking line is the transversal, and then it intersects this blue line and this other blue line at these two distinct points, so here and here. And we number the angles when we're talking about these relationships, because if you think about it, if I use 3 letters to name all these angles, that'd be super tedious. All right, we have a second picture over here with the transversal, which is called line T, and 2 other lines. And this time, you should be able to look at this and tell from these symbols that these lines are parallel. The first vocab term and relationship we're going to talk about you already know, and these are vertical angles. So take a look for a moment and think about all the angle pairs that are vertical. Feel free to pause the video to do this. I'm going to highlight, or I'm going to draw in all of the vertical angles. So if I look, angle, and you know what, I could do it on either picture. So I'm going to say angle 2 and angle 3 are vertical to each other. Angle 6 and angle 7 are vertical to each other. I'm going to use different symbols because 6 and 7 are vertical and congruent to each other, but not necessarily to 2 and 3. Then if we look, we've got angles 1 and 4. That's a pair of vertical angles. And then angles 5 and 8. And you know what? I'm just going to go to a different color for 5 and 8. All right. So I'm not trying to say that angles 5 and 8 are congruent to 2 and 3, just that they're a pair of vertical angles and congruent to each other. So if you look in the diagram to the right, we also have several pair of vertical angles here. Now, I'm not going to go into a ton of detail in this slide as to why this is, but I will tell you that angles 1 and 4 are vertical and congruent. Angles 5 and 8 are vertical and congruent. You'll learn in a few minutes that 1 and 4 and 5 and 8 are congruent to each other. Angles 2 and 3 are vertical angles, and 6 and 7 are vertical angles. We know all vertical angles are congruent. The other review vocabulary we have is the term linear pair. I'm not going to mark all of the linear pairs, but remember that if you have 2 angles that are adjacent and supplementary, like angles 1 and 2, we call that a linear pair. So if we pretend for a second that angle 1 is, 110 degrees, angle 2 would have to be 70 degrees, and they would add up to 180 degrees. So that's what it means to be supplementary. If you look at the picture to the left, I could say, for example, 6 and 8 are also a linear pair. They're adjacent, they share the same vertex, they're supplementary. So maybe angle 6 is like 115 degrees, and angle 8 could be, for example, 65 degrees. So we're used to saying linear pairs. All linear pairs are supplementary. On this slide, we have a new vocab term, and that is corresponding angles. So corresponding angles are going to be angles that are in the same relative position when we have a situation like this where we've got 2 parallel lines cut, or excuse me, 2 lines, not necessarily parallel. These lines are, these aren't. So 2 lines cut by a transversal. There are other times where we'll talk about corresponding angles later in the year, but for now, just know they're in the same relative position to one another. So what I mean by that, and I think it's easier to see on the second diagram, let's look. So if you take lines 1, 2, 3, and 4, in fact, if you take this entire line and move it down, the angles that are on top of one another are parallel. So angle 1 and 5, excuse me, not parallel, they're corresponding. Angles 1 and 5, 2 and 6, 3 and 7, 4 and 8. Oops, I didn't mean to move those. Well, I'll just do this. All right, so if I move, I basically switch the way that we number the angles. 1 is in the position that 5 was in, and 5 is in the position that 1 is in. Okay, so that's not really what I wanted to do. I wanted to move these back up. Here we go. All right, so corresponding angles, again, are in the same relative position. So I could think, for example, that in the top left, I see angles 1 and angle 5. So if I look at both of these intersections, I see angles 1 and 5. If I go over to this other diagram for a second, I still have corresponding angles. So I could say, for example, angle 2 and angle 6 are corresponding because they're both in the top right of their intersection. I could say 3 and 7 are corresponding because they're both in the bottom left. We don't often use bottom left and top right. I just think it kind of helps illustrate, at least for the sake of this PowerPoint. All right, so if we can go back to the situation where we have two parallel lines. You saw me earlier move this pink line down on top of line B. So look again at what happens. When we do that, angles 1 and 5 are really the exact same angle. So if I think about that, angles 1 and 5, if I move this angle down on top of 5, angles 1 and 5 are not just corresponding, but they are congruent. So a big takeaway here is that when these lines are parallel, our corresponding angles are congruent. However, they are not congruent over here in this picture. So angles 2 and 6 are not congruent. And if I look at those, I mean, they don't even look like they're the same angle, but they're not congruent necessarily. On to alternate interior angles. So alternate interior angles are going to be on the inside of the two lines that are cut by the transversal. So I'm just going to go ahead and shade what the inside is. All right, so this is the interior. And if you've ever heard of like an interior decorator, that's someone who decorates the inside of your home. So alternate interior, if you look, we have 4 angles in each of these interior sections. They're going to be ones that are on alternate sides of the transversal, and they come from the 2 different intersections. So angles 3 and 6 here. And you know what? In this left diagram, 3 and 6 are not necessarily congruent, so I'm going to give them 2 different markings. But we could say that angles 3 and 6 are alternate interior. We could also say that 4 and 5 are. But the misconception is that we can't call all 4 of those alternate interior because they're alternate to each other. So I could say 4 and 5 or 3 and 6. The same is going to be true on this diagram. So 3 and 6 are alternate interior. 4 and 5 are also alternate interior on the right. But the thing that happens here, so if you look at where, again, if we bring down, well, I don't know if this is going to work. It's not working for me right now. Sorry. If we were to bring angle 1 down, we said that angle 1 and 5 are congruent. So if I take angle 1 and I know it's congruent to angle 5, well, we know that angles 1 and 4 are vertical angles. So that also means that angles 1 and 4 are congruent. So I could really say that if angle 1 is congruent to angle 4 because they're vertical, and angle 1 is congruent to angle 5 because they're corresponding, well, angles 4 and 5 must be congruent. And just to refresh your memory, that's an illustration of the transitive property of congruence. We're going to definitely talk about that in the next few days. So alternate interior angles are congruent when the lines intersected by the transversal are parallel. All right, now we're on to alternate exterior. So the exterior angles are going to be the angles that lie outside of the two lines intersected by the transversal. And just like alternate interior, alternate exterior are going to be on alternate sides of the transversal and from two different intersections. So, for example, 2 and 7 on both diagrams, angle 2 and angle 7 are alternate exterior. Also, on both diagrams, angle 1 and angle 8 are alternate exterior. So if you look on the right diagram, I'm going to also bring out angles 2 and 7. And again, you might have guessed that when these lines are parallel, so I'm really looking at this right diagram with the parallel lines. When these lines are parallel, there's a special relationship between the alternate exterior angles. So again, we can kind of use the transitive property to understand it. So we already know that angle 2 is congruent to angle 3. And why are those congruent? Because they're vertical angles. Vertical angles are always congruent. Now, we learned earlier that corresponding angles are congruent. So if I look, angle 3 is in the bottom left intersection, or excuse me, the bottom left part of this intersection. And if I look down here, it's also the bottom left of this intersection. So if I were to take this angle and basically translate it down, it would lie on top of angle 7. So these 3 and 7 are corresponding angles. So again, we could conclude that if 2 is congruent to 3 and 3 is congruent to 7, that 2 and 7 must be congruent. So our special relationship is that all alternate interior angles are congruent when the lines intersected by the transversal are parallel. On to same-side interior angles. So interior, again, we are still talking about the angles between these two lines. Same-side interior are going to be angles that are on the same side of the transversal. So for example, in both diagrams, angle 4 and angle 6 are same-side interior. Additionally, angles 3 and angles 5 are same side interior. So that's true for both diagrams. Now, same side interior angles are never congruent. So we don't want to mix those up with alternate interior. But what we do want to know is that there's still a special relationship. So for our same side interior angles, let's consider on the right diagram. So again, there's no relationship on the left. These lines are not parallel. But on the right, we have two parallel lines cut by a transversal. When this happens, special things occur. So if you look at our same side exterior angles, angle 4 is interior. Angle 4 is same side interior to angle 6. So if we think about this for a second, and you're maybe wondering how they're related. Well, if I were to move these down, I know that angles 2 and 6 are corresponding angles. So 2 and 6 are congruent. If I move this back up, I could see that angles 2 and 4 form a linear pair. So let's go back and say what we know. We said 2 and 6 are congruent, 2 and 4 are a linear pair. So what we can conclude is that 2 and 4 are supplementary. We also know that angle 2 is congruent to angle 6. So I could really substitute the measure of angle 6 for the measure of angle 2 to conclude that angle 6 and angle 4 are supplementary. So the big idea here is that when these lines are parallel, same side interior angles are supplementary. In this slide, we're talking about same side exterior angles. So exterior, we're still looking at the angles on the exterior side of the exterior side of the two lines. But we're going to be looking at angles on the same side of the transversal. So for example, angles 2 and 8. So I'm going to say angles 2 and 8 on both diagrams. Also, angles, that 8 looks like a B. Ugh, and I just made it worse. I'm sorry. That's going to really annoy me. Okay. That doesn't look much better. Also, angles 1 and 7. So these are all same side exterior angles on both diagrams. Just like same side interior, they have a special relationship. So try to follow this logic here. Let's look at angles 2 and 8. When I'm talking about the special relationship, it only exists when we have parallel lines cut by this transversal. So angle 2, I'm going to mark angle 2. I know for that angles 2 and 4 are a linear pair, just like we said before. So I could say angle 2 and angle 4 are supplementary because all linear pairs are supplementary. Then if I look, I know angles 4 and 8 are corresponding. So angle 4 is congruent to angle 8 in this diagram because corresponding angles are congruent. Therefore, angle 2 and 8 are also going to be supplementary. So when two lines are parallel, all same side exterior angles are supplementary. I know there has been so much information in these slides, and it takes a while to sink in, but let's summarize. Vertical angles are always congruent. It doesn't matter if we have parallel lines cut by a transversal or vertical angles anywhere else. Linear pairs are always supplementary. Those relationships always exist. But when we have two lines that are cut by a transversal and they're parallel to one another, we need to know that there are congruent angle pairs and supplementary angle pairs. The congruent angle pairs are vertical, which are always congruent, alternate exterior, alternate interior, and corresponding angles. The supplementary angle pairs are the linear pair, same side exterior, same side interior. This one slide is absolutely the big idea, the main idea from this lesson.